Hi class. So we'll look at the final section of unit number 2, which is looking at solving radical equations. So we've done this kind of stuff before in Math 11. But we'll kind of use the graphing as well. So let's look at the first one here. So let's do this algebraically first, and then we'll do it with the graphing. So the first thing you want to do is you want to identify any restrictions. Okay, so identify restrictions. So remember, the root itself has to be greater than or equal to 0. Right? Because it can't be negative, because then you have you're taking the square root of a negative. So in this case here, x has to be greater than or equal to -2. So why that's significant is when we solve, and if we get especially if we get multiple answers and one of them violates that, then it's what we call extraneous. It cannot be a solution. Okay, so now we can solve. So we've got we can go root x. Remember, we're looking for the roots, right? So if you think about the graph, that's where you cross the x-axis. So what we want to do here is we want to set y to be equal to 0, which is what you do when you solve for the x-intercepts. Okay, and we'll move the 4 over. Okay, so we want to get rid of the square root, so we'll square that side, and then we square the 4, so we get x plus 2 is equal to 16, so x equals 14. Okay, so that's our answer. Okay, now the other way you can do this is through graphing. So I'll just I'll use the Desmos here, which I showed you on the previous topic. How to so we could graph it on paper, but I'll just use the Desmos approach. Okay, so let's graph this. So we got y equals square root of x plus 2. Okay, how do we go to the get out of this? Oh, I think you press square root again. No, that's not what you do. I think it might be some type of space function here. There we go. So you press that arrow, and we've got minus 4. Okay, so I can't see it. So remember, you can manipulate by zooming in and out. So if I just kind of expand this a bit. Okay, so there's where it crosses. And then you can, if you put your finger on that spot there, you can see what that spot corresponds to, and that's 14. So that's saying x equals 14 and y equals 0, okay, which is what we got algebraically. Okay, let's look at another one. So this one's a little bit different because you've got variables on both sides. So what you would do here is you want to graph both of these at the same time, right? So and what we're looking for here is we're looking for where the two lines intersect. Okay, so the intersection point is your solution. So again, let's use Desmos to figure that out. Okay, so we got square root of 6 minus x. Okay, so that's one graph right there. Okay, and then what we'll do here is if we press the return button, that'll give us allow us to do a second graph. And so the second graph, what we're going to do here is we're going to set that to y equals 4 minus x. Okay, and so here's the blue line here is that second equation, and so here's your interception point, and that's going to be 2, 2. Okay, so 2, 2 then would be, or x equals 2 would be the solution. Okay, and so what we can do now is we can, the intersection point here is x equals 2. Now, one thing we can do with these type of questions is we can verify to see if this is the case. And the way the verification works is you basically sub in that, and you want to show that the left side equals the right side. So our equation here is 4 minus x equals square root of 6 minus x. So 4 minus x is going to, 4 minus 2, and then 6 minus x. And so that's going to be 2, that's going to be the square root of 4, so 2 equals 2. Okay, so the left side equals the right side. So if we had gotten like 2 equals 4, then what that tells you is the answer that we figured out is incorrect. Okay, so this is something you can always do to check to see if your answer works. Okay, so let's do another one, and we'll use the Desmos again, and we'll also use we'll look at this one because it's a little more complicated. We'll do this one algebraically as well. Okay, so let's look at the graphical approach first. Okay, so we've got, let's delete that one here. So this one here is 12 minus 2x squared. And then the other one here, we'll make that x plus 3. Okay, so what you've got here is you've got two solutions. We've got one there, and so this is 0.414 and 3.414. So I mean, there's no way you're going to be able to get that by graphing it by hand. Okay, so some of these ones are like that. You're going to have to use the technology to get that get it that precise. And then the other answer here is negative 2.414 and 0.586. So again, there's no way you would be able to get that precise of an answer by graphing by hand. So hopefully you've all have some experience using this app. If not, just send me a message and I'll see if I can help you with that. Okay, so we got our answers from the graph. So now let's look at doing it a different way here. So again, algebraically, so we'll go with that. Let's look at the restriction here. So we've got we're looking at inside the root. Okay, so 12 minus 2x squared has to be greater than or equal to 0. And so what we have here is negative 2x squared has to be greater than or equal to negative 12. Okay, and so what you have is x squared is greater than or equal to 6. So you're going to square x, right? So it doesn't really matter what it is. It's always going to be positive. So the way I'll write this down is the absolute value of x has to be greater than or equal to root of 6. Okay, so again, if it's not equal to that, then it's not a correct answer. Okay, so there's two possibilities here. So case one, if x is greater than or equal to 0, so it's like x is like a positive number, then your value has to be greater than or equal to root 6. So this is just following with the absolute value. And then the second case would be if x is less than 0, then x has to be less than negative root 6. Okay, so let's so again, the idea behind the restriction is to validate your answer. Okay, and you're looking to see if there's any extraneous answers. Okay, so let's do the algebra now. Okay, so we got x plus 3 equal root 12 minus 2x squared. And we'll square both sides here. So that gives us x plus 3 squared, which is x plus 3 and x plus 3. And then here we've got 12 minus 2x squared. So we'll expand that, which gives us x squared plus 6x plus 9 equal to 12 minus 2x squared. Okay, and now collect all the like terms and put it in the proper format for quadratic. So you've got 3x squared plus 6x, and then minus 3 equals 0. So you should recognize this format. So what you have here is A, B, and C. Okay, so if you remember your quadratic formula, negative b plus or minus square root of b squared minus, I'll just write down here, so that your quadratic formula, so when you're solving for something like this, it's going to be negative b plus or minus b squared minus 4ac over 2a. So this is what you would use if you're unable to factor it using traditional methods. So it's too complicated, which it is in this case. So now just put that in. So you've got negative 6 plus or minus b squared, which is 6 squared minus 4 times 3 and negative 3 AC. And then that's all over 2 times 3. So that gives you negative 6 plus or minus 36 plus 36, because there's a negative and a negative, and that's all over 6. So that gives you negative 6 plus or minus root 72 over 6. Okay, so you've got a negative 6 plus the square root of 72 divided by 6, and you have negative 6 minus the square root of 72 over 6. So it gives you two answers. So if we work that out and then just approximate it with decimals, so like actually take the square root of 72, what that's going to give us is, and this is what we got with the decimals, that's going to give us two answers, so 0.414 and negative 2.41. Okay, which is what we had from the decimals. Okay, so those are your two x solutions. All right, so I'll stop there. So that concludes this unit, Unit 2 on radical functions. Okay, so we'll stop now.